This video is for 16 through 21. So in number 16, we have a 90 degrees and a 45. So there's another 45-degree angle. So this is a 45, 45, 90. Remember, across from the 45 is our L side, and across from the hypotenuse is L root 2. Now, if we know the L root 2 side, which is the hypotenuse, we need to divide by root 2. So we're going to do 10 divided by root 2, and we have to rationalize. So we're going to multiply root 2 over root 2. So we get 10 root 2 over 2, which reduces to 5 root 2. So x is 5 root 2 and y is 5 root 2. 17 is a 30, 60, 90 triangle. So across from 30 is s, across from 60 is s root 3, across from 90 is the 2s side. So this time we know we need to find s again. So we're going to do 12 root 2 divided by root 3. Now those roots don't divide together, so we have to rationalize by multiplying root 3 over root 3. So we get 12 root 6 over 3, which reduces to 4 root 6. So x is going to be 4 root 6, and y is going to double to be 8 root 6. Now, 18, because these legs are marked congruent, they're both 4 root 5. If the bottom part's also 4 root 5, that means this is an equilateral triangle. So when we draw in the altitude, we actually have a 30, 60, 90 triangle, which means that these sides on the bottom are also split. So if the whole bottom is 4 root 5, that means that y is 2 root 5. And then to get x, we're going to multiply by root 3 because this is the s root 3 side. And so when we multiply by root 3, we would get 2 root 15. 19, find the exact perimeter of the trapezoid. So first we're going to start with this 30, 60, 90 triangle. And we know that we have the 2s side, s root 3. So if 2s is the 18 root 6 side, we have to divide by 2. So s is 9 root 6. So the side is 9 root 6. Then we have to multiply that by root 3, which 9 root 6 times root 3 is 9 root 18. We have to simplify 18. So we would have 9 times 3 root 2, which would get us 27 root 2. So the altitude of the trapezoid is 27 root 2, which will help us in the triangle on the other side, which is also 27 root 2. So on the other triangle, it's a 45, 45, 90. So we have 27 root 2 for the other part of the leg. And then the hypotenuse of that right triangle, we're going to multiply by root 2. So we would have 27 root 2 times root 2, which would get us 27 times 2, which is 54. Now we also know in the rectangle, or in this rectangle here, if the top is 25, the bottom is also 25. So when we go to find the perimeter, we would have 18 root 6 plus 25 plus 54 plus 27 root 2 plus 25 plus 9 root 6. So we can add the root 6's together. So 18 root 6 plus 9 would get us 27 root 6. Plus 27 root 2 stays by itself. And then we can add up our constants. So we have 25 plus 25 plus 54 would get us 104. In number 20, a support cable for a 50-foot degree angle with the ground. If the cable goes to the top of the tower, how long must the cable be to the nearest hundredth? So we have our tower that is 50 feet. There's a 60-degree angle with the ground. The tower is going to be standing straight up, so that makes our right angle. We want to know how long the cable is. So across from the 60 is the s root 3 side, and we want to find the 2s side. So first we need to do 50 divided by root 3. So we get 50 root 3 over 3 once we rationalize. And then we have to double it, so that means that the x is going to be 100 root 3 over 3. And rounding to the nearest hundredth, we can just put all of that into the calculator. So 100 root 3 divided by 3 would get us 57.74 feet. 21. If an altitude of an equilateral triangle is 8 root 3, find the perimeter. So in the equilateral triangle, remember that an altitude creates our 30, 60, 90 triangle. Root 3. That's the S root 3 side. So when we do 8 root 3 divided by root 3, we get 8. So the S side is going to be 8. The 2S side is going to be 16. So that means each side of the triangle in the equilateral triangle is 16. So our perimeter is 3 sides times 16, which would be 48 meters.